Okay, in this question we want to find the integral of sine 3x times tan squared 3x. And in order to do so, we have to use trig identities and use substitution. So the first thing we want to do is convert tan squared 3x into sine squared 3x divided by cosine squared 3x, like this. And we know that sine squared x is equivalent to 1 minus cosine squared 3x. And now we will do u substitution. So if we say that u is equal to cosine 3x, our du is negative 3 sine 3x. So we can say that negative 1/3 du is equal to sine 3x. This will allow us to have cosine squared 3x. We'll have a u, and we would have a negative 1/3 in the front. So like this. And the next thing we want to do is try to clean it up a little bit. So we'll have the negative 1/3 of the integral 1 divided by u squared. And u squared divided by u squared would be 1, so minus 1 du. And now we are pretty close. So we'll write this in a better form so we can get the antiderivative. So instead of 1 divided by u squared, we can say u to the negative 2. Negative 1 stay the same. And now we do the antiderivative. So the antiderivative of u to the negative 2, so you add 1, you'll get negative 1, and then we divide by negative 1. So that's going to be negative 1 over u, and negative 1 would produce negative u, plus the arbitrary constant c. And now we plug in what we originally had for u, so cosine 3x. So our final answer is going to be negative 1/3 times parentheses negative 1 divided by cosine 3x minus cosine 3x plus the arbitrary constant c. And that's all we need to do.